This is not the S in the homework, but it's kind of like it, right? Let's see here. Let's think about we're having S going from R3 to R2, right? And I've got this T over here that goes from R2 to R2. I think I can compose these, right? I could look at S composed with T, right? That would go from R2 to R2 to R3. Oh, nope, couldn't do that. Let's try that again. Maybe T composed with S would make more sense. So S would go from R3 to R2, right? And then my T goes from R2 to R2. Okay, so that makes sense. For my example, I can look at T composed with S, right? And the claim is that the matrix of T composed with S, right, should be the matrix of T times the matrix of S, which we could calculate. T was what? My example, I've lost it already. 3 minus 1, 0, 4. Matrix of S was what? 2, 0, 1, 0, 3, minus 1. We multiply these matrices, what do we get? 6, 0. Oh, wait a minute, can I multiply these? Yeah, I can multiply these, sorry. Oh, sadness. What should we get? What kind of matrix should we get? Sorry, I'm having a mental block here all of a sudden. So you guys tell me what the output is, 2 by 3, yeah? Six, then what? Are you reading across the top row, or? Yeah. 6, then what? Negative 3. 4. Okay. Then 0. Negative 4. Okay. I'm sorry, I have some sort of mental block against doing that matrix multiplication right now. Isn't that sad? So on the other hand, we can calculate T composed with S of what? Of UVW directly. So that would be T of S of UVW. Right? We can just calculate the composite. So that's T of what is, well, that for me was 2U plus W, 3V minus W. So in this, basically, we have X equal to 2U plus W, right? And we've got Y equals to 3V minus W. You know? And so I'm supposed to get 3x, right? So it's 3 times 2u plus w plus 4y, which is 4 times 3v minus w. And then my next one is 4 times the y, which is 3v minus w. Which when we multiply that out, we got ourselves a what? 6u. 3v minus, so minus 9v. How many w's do I got? I got 3 of them here. I got minus 4 of them here, so I got a minus w. And then over here, I've got myself a 12v minus 4w. Right, so if you look at that directly, we can calculate the standard matrix for the composite just by direct computation of the composition. And so, oh, I did something wrong. What did I do? Oh, it's just minus y. So that 4 is in my mind, but only there. So this is supposed to be a minus, right? Right? Okay, good. And that changes the calculation a little bit. We get 6u still. Then we get plus 3w, so 4w, right? And the 9v is wrong. It should be just, looks like minus 3v. It doesn't affect the other one. So that gives us a 6, a -3, a 4 for my top row, and a 0, a 12, and a -4 for my second one. And that should be the same as I got just directly multiplying the matrices, right? So that question we're talking about, which was what? 79, right? So I said, calculate the formula for S composed with T of xy. Oh, well, this T goes from R2 to R3. It's a little bit different, right? So this example is like it, but not exactly the same. So for part A, what I'm asking you to do is essentially this, right? Part A is just to calculate the composite. And then actually part B is this. This is actually, this piece down here would be part of part B. Put some quotes on it. That's part of part B, to find the matrix of the composite, right? And then part C is actually analogous to what I did up here, to check that when you multiply the composed transformation standard matrices, it works out to the... So really, I'm just trying to exhibit the thing I proved in the video you haven't watched yet, which was this. The proof of which, by the way, is almost easier than the calculation we did. It makes me happy in linear when we can prove something in general in a way which is in some sense easier than actual examples we do. That is kind of demonstrates to you a little bit about why linear algebra is so powerful, the efficiency of the arguments. Now, the next thing, of course, is how do you find the standard matrix? Well, not the non-standard matrix of something like this. If we had T of, say, f of x equal to f prime of x, or say f prime prime of x, I'll explain how to find the matrix of T with respect to, say, the beta basis. This is for like f of x and P2, you know. So tomorrow, probably in class, if it doesn't get canceled. Anyway, I will be there. I have a 8:15. We're not going to cancel the 8:15, like I'm pretty sure. So I'll be here. And I plan to come to class and answer questions, probably just work through mostly examples like that for you guys, because a lot of your homework is more or less just finding the matrix of a linear transformation with respect to a non-standard basis. So the little sub-betas and gammas, those have to do with running through a similar calculation, but with respect to a basis. So there are already a couple of examples of those posted, both in the notes, obviously, but also in the video that I've posted that you haven't watched. So anyway, sorry to take so long to answer your question, Emily. You guys have any other lingering? Oh, in case you may not have checked your announcements yet, I pushed the homework back to Wednesday. I guess the word of that probably got around already, though. Yeah. I did put it at the end of the announcement. It's not in the title. So there are some of you. I'm deliberately punishing the people who don't read to the end of the announcement. Like, that's deliberate. I know who you are. I don't know why I'm saying this right now, right here, because those same people wouldn't be watching this, right? So, and are not here. So that's why it's fun. It's most fun to make fun of people when they're not there, right? Is that part of the Liberty Way? No? It's not? Okay. I think that's just basic Southern etiquette, right? No. Sorry.